Okay, so for this section, I want to talk about applying exponential functions. So in the first section, for chapter 4, we just kind of laid down the groundwork of what an exponential function was. So now I want to find some applications. And I'm not going to go very deep into this just because it's going to be heavy in our finance section for chapter 5. So I just kind of want to show you a few examples, but we will revisit this when we get to chapter 5. So we'll just talk about an exponential growth function, and then we'll just apply it to a couple finance situations. All right, so under normal circumstances, just meaning we have, like a kind of regular growth or decay, we can represent that exponential growth as a function. So here in the book in 4.2, it does change the variables and what they are, but you can just think of y naught, which is that little y to the 0, as c. Okay. E to the k stays the same as it did in the previous section 4.1, but b here, which is kind of just interprets to base, works the same way as a. Okay, so everything operates the same way. But instead of having an equation, now we have a function that we can change the value of t and figure out some things with it, okay? So here is the first, our first application problem, credit cards. So, and just assuming that you do not know what a credit card is. A credit card is a card that has a certain balance on it, whether, a balance here is what we owe. So if you spend $500, it's like you're loaning, or you're getting loaned the $500 and you're expected to pay it back with interest. All right, so for this section, or for this question, given the interest rate is 1% and the minimum payment's 3% of the balance, then, and t is the number of months, then this function develops out of this. Okay, you're not responsible for being able to find this function given the interest rate and minimum payment yet, but it's just a given function. And so we want to know what is the balance after 6 months. Okay, so t represents our number of months. Okay, so that's a big component here to be sure that you understand and pay attention to what unit your independent variable, normally t, is in, because it could be in days, hours, years. Here it's months, weeks, etc. Okay, so just make sure you pay attention to that aspect. All right, so for number 1, what is the balance after 6 months? Okay, so I just need to figure out what f of 6 is. So I could use my calculator, Desmos, whatever calculator you so desire. And I just want to plug in 500 times 0.9797 raised to the 5th power. Okay? So when I do that, I get $451.27. Okay? So I just found out what that function at 6 was. Okay? So here would be a great place to stop and kind of check yourself. All right, if you remember, our condition for decay was a was between 0 and 1. Okay, well, we can see 0.9797 is between 0 and 1, so we would expect our values to get smaller as we plug in bigger t's. Obviously, it went from 500 to 451, so that's good. All right, here's why you have to pay attention to your units for number 2. So we want to look at 1 year, but I'm in number of months, so I am not looking at f of 1, but I am going to look at f of 12 because there are 12 months in a year. So I go to my calculator, I just plug in, raise it to the 12th power, and I get $390.92. So $300 or $390.92. Okay. All right, so go ahead, pause the video, and try out number 3. All right, so assuming you pause the video. So for 5 years, I don't want to look at f of 5 because I'm talking about months, but there are 12 months in a year, So 5 times 12 is 60, so I need to look at 60 months. All right, so I'm going to look at f of 60. Go to the calculator, plug it in, and I get 146. Make sure you know that's a dollar sign there and not a 1. I'll try that again. Okay, so I get $146.07. Okay, and so my balance would continue to get smaller until eventually I would theoretically hit 0. Okay, all right, so that is one application of this. We'll have a few more different applications to talk about in Chapter 5, but this is just a kind of intro application. All right. So our next application here could be, to any kind of currency. For this one, we'll talk about cryptocurrency. And we know 2 points. So we know that, or we suppose that the value of Bitcoin was $80 billion in January 2020. And it grew to $500 billion in January of 21. So we want to write a function that models the data. And we'll say that t equals to 0, or when t is equal to 0, we're talking about January of 2020, and t represents the number of months. Okay? So just like with a linear equation, we can, when we know 2 points, we can write a function from that. We can calculate the slope, y-intercept, all that, right? So kind of think of that as the same thing we're doing here. We have 2 points, okay? What are those 2 points? Well, first, I know that my initial value is when January 2020, because that's at 0, and that was 80 billion. So I know that y naught has to be 80. Now I could find that by saying, well, 80 is equal to y naught times b. I don't know what b is, but b raised to the 0 power, and I get y naught is equal to 80. So it's the initial value when t is 0. Okay. Our second point, we have 500 would be equal to our y naught of 80 times b, and we know that it's after 12 months because January 21 is 12 months after January 20. Okay. So I just raised that to the 12th power for t, so I want to solve for b. Well, I can solve for this just, using some algebra steps. So I get 80 divided by 80. So I have that 500 divided by 80 is equal to b raised to the 12th power. Here's a confusing step that gets some people, so I just kind of want to explain this good, hopefully. So if this were b squared, we know that we would take the square root of it, okay, to both sides. Well, we can do that same thing no matter what the power is, but we're just going to take whatever the power is, the root of it, okay? So for this one, we'll take the 12th root. Well, to do that, just as a reminder, right, the square root of x is equal to x to the 1/2 power. So we can rewrite this as a fractional exponent. Okay? So the 12th root can be written as 1 to the 12th, or 1 over 12 power, so 1/12 power. And I can do that to both sides. When that happens, those multiply together to give me 1. So b is then equal to 500 divided by 1/12 power. Make sure it's the whole quantity and not just your 500 or your 80, but it's 500 over 80. And so when I do that, I get that b is equal to 1.165. Okay, so now I have a function. So my function is f of t is equal to 80 times 1.165 raised to the t power. Okay. So that is my function. Now I can plug in whatever value of t I want to, and I will get some kind of answer out. All right, so if the model stays accurate, what is the value in February 21? So January of 20 was 0 months. January 21 was 12 months, so we're 1 month past that. So we're going to look when when t is 13. So I just plug t is 13 into my function, and I just simply go evaluate it in the calculator, and I get 582, we'll call it 583 billion. Okay. So in February 21, that would be 583 billion would be the value of Bitcoin. Okay. Now the third question here, what is the first full month when Bitcoin is worth 300 billion? All right, so later in chapter 4, we will discuss more about how to solve for this. Okay? But for now, we can use trial and error because we have a function. So I do have the function, and all I need to do is pick out some values that work for, that will see where 300 billion happens, okay? I could start at 1, or 0 technically, but I could start at 1, 2, 3, whatever I wanted to start with. And just through a little bit of common sense here and deductive reasoning, we know that if it's 80 billion at 0 and it's 500 billion when t is 12, then I know I need to look between those two. So let's just pick out a random number. Let's say that it's, let's start with 6. Okay. So I go to my calculator and I just evaluate where this function is at when it is 6. So f of 6, I get 200. So that's not good. That's not what we're looking for. Let's try f of 10. Okay, when it's 10, I get 368. So I know that I'm between there and I'm close. So let's try 9. And so at 9, I'm about to run out of room here. At f of 9, I get 316. Just to be sure, f of 8 is 271. So I know that it is when t is equal to 9. And that is in the month of September. Okay. So that's just another application of exponentials and how things exponentially grow. Money grows exponentially a lot or decays exponentially. It's usually not a linear situation when we talk about money. All right, so that wraps up 4.2. We will get into 4.3 for our next section, but there is a homework on 4.1 and 4.2. So if you have any questions, please let me know, and have a great rest of your day.